Welcome! Have you guys heard about quantum theory? In very simple terms, quantum theory is a part of physics that describes the behavior of the universe at a tiny scale. So today we're going to show you some very interesting things that happen in the tiny world. Things that we cannot just see. For years, scientists have been studying how the real world works and coming up with many theories, laws and formulas that can be used to predict everything in nature. It's like having a superpower. It wasn't until the 1700s that scientists realized not everything that happened in the big world happened in the small world of atoms. Things in our world can behave really differently. They might behave like waves or like particles. But when you hear the word particle, what do you think about? What is particle? Basically, a particle is a piece of matter. It can be anything. It can be this table. It can be a baseball. Or maybe a grain of salt. It's got to be part of something. Usually a diminutive part of something. What about waves? When you hear the word wave, what comes to your mind? Ocean waves? Sound waves? Do you realize that when you are listening to music, you're exposing your ears to waves? So yes, waves are vibrations that propagate through air and matter. The experiment we're about to show you was extremely important for the scientific work because it showed the behavior of particles at a very small scale.
To make the experiment a little bit easier for a family audience to understand, we created an interactive activity showing how the double slit experiment works. As you can see, we have a plate with many pieces of slime that represent the particles. They have to be thrown one by one with the goal to pass through one slit. Some of them will bounce off the screen and fall to the ground, but the ones that do pass through stick to the wall, forming a very intuitive pattern in the back. As expected, when particles are thrown through one slit, they leave a single vertical pattern on the back screen. Now, what if we add a second slit to the experiment? Would the pattern in the screen be different, or would it be the same? Let's take a look. If marbles were now thrown through two slits, we would end up with two vertical patterns. You already knew that, didn't you? That's because particles behave in a pattern that we can predict. Remember the superpower we talked about earlier? It's the magic of mechanical or classical physics.
If we perform the same experiment with waves, the results will be slightly different. Let's say we propagate a wave, so it passes through one slit. The wave will hit the slit and radiate out, so the part with most intensity on the back wall will be directly in front of the slit. With one slit, the wave behaves just like the particle does. However, if we add the second slit, something different happens. The wave will pass through both slits and will start interfering with each other. Some will cancel out, causing a very specific interference pattern to occur on the back screen. In other words, when we throw matter through the slits, we will get very well-defined patterns. But when waves pass through the slits, there will be many of them. Where the wave cancels out, there will be an empty space, and where it hits the back wall, there will be a mark.
So the same experiment was performed, but this time we threw electrons through the slits, and guess what happened? For our surprise, the pattern in the back wall suggests that electrons have wave properties. Right now you're probably thinking, how did that happen? That is exactly what scientists at the time wondered too. How did the electron change its path after passing through the slits? Scientists decided to take a very close look at what was going on as soon as they passed through. If you were a scientist, what would you do to observe that? Well, what they did is they installed a camera right next to the slit to observe exactly what these particles were doing after they passed through. The problem was, something even crazier happened. The pattern on the screen changed again. Now, the electrons behaved like particles. If this concept sounds odd to you, imagine how confused physicists felt about it at that time. After all of Einstein's dedicated work, after all those laws and formulas that were supposed to predict the behavior of things in the universe, this simple experiment changed the way physicists looked at the world. It was impossible to describe everything in our universe using only the laws of classical physics. And don't get me wrong, classical physics is genius and it works. But quantum theory has shown us a whole different perspective.
After all of this crazy information, what do you guys think about quantum physics? To me, it's such a fascinating subject that shows how complex the world is. There is so much we still don't know, and that's the beauty of it. There is a whole lot of scientific discoveries to come, and the world needs more quantum enthusiasts to pitch in their ideas, explore, and hopefully find answers to some of the big questions like, where do we come from?